Welcome to clickmyprojects.com. Now we will discuss about the paper on MIMO configuration mode and MCS level selection scheme by Fuzzy Q-Learning for HSPA plus systems. What is HSPA plus systems? HSPA is a high-speed packet access evaluation systems. It is a wireless broadband standard defined in 3GPP release 7 and 8 of the WCDMA specification, and it provides data rates up to 84 Mbit by second in the downlink layer and 10.8 Mbits per second in the uplink. Next one is MIMO. MIMO is a multi-input, multi-output technology and is the use of multiple antennas at both the transmitter and the receiver to improve the communication performance. Next one is HERQ. HERQ is a hybrid automatic repeat request. It is a combination of forward error correction with ARQ error control. In HERQ, the original data is encoded with a forward error correction code and the parity bits are either immediately sent along with the message. If any error occurs in that stream, the HERQ system uses fallback to correct errors. What is BLER? BLER is a block error rate. BLER measurement is often used as a quality control measure. Okay, next one is MCS. MCS is a modulation and coding scheme. In this paper, we are using 8 levels of MCS. Each MCS level contains block size, modulation order and coding rate. Next we see the abstract of the paper. An important issue in HSPA plus system is to choose a modulation and a coding scheme for new data packet when channel quality indicator is inaccurate. In this paper we propose a fuzzy Q-Learning based MIMO configuration mode and a MCS level selection scheme for HSPA plus system. The main challenge of the system is the selection of MIMO configuration mode and MCS levels for new data transmission of HERQ under the situation that the channel quality indicator has a report delay. The FQL-MOMS selection scheme combines the fuzzy logic and Q-Learning algorithm to intelligently choose an MIMO configuration mode and MCS level for packet data transmission in HSPA plus systems. The main use of this system is to enhance the system throughput while guarantee the BLER requirement. This is the system architecture of our proposed work. Node B needs some control information from UE. This information consists of PCI, CQI and BLER values. The CQI contains the channel quality indications of the primary and the secondary data streams. This is denoted by CQIH and CQIL. The values of CQIH must greater than or equal to CQIL. The values of CQIH and CQIL are measured by UE are on integer ranging from 0 to 14. The measured BLER, CQI values and system information are sent to FQL-MOMS selection scheme. This is the function blocks of the FQL-MOMS selection scheme. The MIMO translation mode with the MCS level is tightly related with channel quality and the resulted performance metric BLER. The FQL-MOMS selection scheme chooses 3 measures to be the input linguistic variables. They are BLER, CQIH and CQIL. Fuzzyfier receives the system state vector as input linguistic vector. There are 2 fuzzy rule bases designed in the FQL-MOMS selection scheme, that is fuzzy rule base SD and fuzzy rule base SM. First one is used for SD transmission mode and the second one is used for SM transmission mode. First we define the membership functions of BLER, CQIH and CQIL using max product operation. In the learning process, we have divided each fuzzy rule base into 3 regions according to fuzzy terms of BLER. The regions are satisfaction, attention and violation. Each fuzzy rule base SD and SM is designed for satisfaction, attention and violation regions. The optimal action for each transmission mode is inferred from corresponding inference engine. A most suitable action for rule J in fuzzy rule base SD can be obtained from select max strategy in inference engine. It is also called the greedy action. Then the optimal action for the SD transmission mode and Q value for this transmission mode is also calculated. Using the same strategy, a most suitable action for rule J in fuzzy rule based SM and the optimal action for SM transmission and the Q value for this transmission is also calculated. The output value of the FQL MOMS selection scheme should be an integer. The optimal actions are rounded off to be integer values. The proper transmission mode at every episode can be decided in the action decision block using select max strategy. If the output is equal to 1, then the FQL MOMS selection scheme selects the SD transmission mode and the outputs of MCS SH only for primary data stream, and the output is equal to 2, then it chooses the SM transmission mode and outputs MCS H and MCS L for both primary and secondary data stream. This mapping table is used to mapping between the MCS levels and the action levels. In this paper, we are using totally 8 number of MCS levels for both MCS H and MCS L. Finally, the FQL MOMS selection scheme can determine an appropriate MIMO configuration mode and MCS level for packet data transmission in HSPA systems. It can indeed achieve an excellent balance between the system throughput maximization and BLER requirement fulfillment. Next, we see the running procedure of our project. First, open the NetBeans IDE and open MOMS project into NetBeans. Then run ue.java. Right click the ue.java and click run file. First, select the CQIH value. The value lies between 0 to 14. Okay, we select 4. Then we select the CQIL value. We select 1. Then we enter the BLER value. BLER is 0.8. Then assign the pre-coding control indication, that is 4. Then enter the system informations of frequency and bandwidth. Then we click FQL MOMS selection scheme. The requirements are sent to FQL MOMS selection scheme. Then click Apply FQL MOMS button. In our algorithm, the fuzzy rule base SD in attention region and SM is also the attention region. It is based on BLER measurement. The inference engine for SD is 5.0 and the SM for 4.0. In the action decision block using select max strategy that selects the maximum value, that is 5.0. The 5.0 is the SD in SD transmission mode. So that selects only primary data stream, that is MCS H is equal to 5. The MCS level is 5. The corresponding transport block size, modulation and coding rate are displayed. Then we click the HARQ scheme. The selection scheme sends the MCS values into link adaptation. In the link adaptation, first enters the data stream. The streams are zeros and ones. Then click the link adaptation. The MCS values and data streams are sent to HARQ scheme. The size of the data stream is 9. Okay. Then click the HARQ scheme button. In the HARQ scheme contains both error correction and detection. First detect the error and the HARQ control scheme that correct the error. In this process, no errors in the original stream. Then we click the spatial processing. In MIMO, both the transmitter and receiver using 2 antennas. In spatial processing, only primary streams are sent to UE because our selection scheme select only MCS H. Click transmit button. The streams are sent to UE through 2 antennas. Thank you.